Okay, quick look at parallel perpendicular lines on line graphs, just so we don't get it in tomorrow. Just look at question 14, which is in your revision booklet 1. So the first thing is, write down the letter of the line that is parallel to y equals x plus 6. So the key thing to remember here is that parallel lines have the same gradient. Okay, this means that the slope is the same. So for example, if that was the line of y equals x plus 6, then if it was parallel, the gradient would be y equals x would be the same. Remember, this is the gradient, this is the intercept on the y-axis, so intercept on y-axis, and it's this bit that changes. So if we've got y equals x plus 6, this would be y equals, let's say, x plus 4, and these lines are parallel. So we are looking for a gradient of x, so 2x, well that's not the same gradient, so it's not this one. X plus 5, it's that one. Let's just confirm, minus, half an x, that's not the same, minus 2x, that's not the same, minus half an x, that's not the same. So the letter of the line that is parallel is the letter R. Okay? Now, perpendicular lines, again it relates to the gradient, and what we're looking for here is we're looking for the, I'm going to call it the inverse reciprocal of the gradient. Okay? That will give us the lines that are perpendicular. So this gradient here, this is the equivalent of 2 over 1. So the inverse reciprocal, we just flip it on its head. So we've got 1 over 2, but it's the inverse, so it's going to be negative 1 over 2. So again, same process, let's just have a look through. So 2x, no. X we've already used, no. Half an x, it's half, but it's not negative. Minus 2x, minus half x plus 6. So it's this one here that we're looking for a perpendicular line to y equals 2x minus 1. Okay, so to find coordinates of the point where the line y equals 2x plus 5 cuts the y-axis and the x-axis. If it's cutting the y-axis, it basically means that, let's just have a little think. Let's see if I can draw a graph. Put it on the page somewhere. Let's do it here. So if this is my graph, okay, when it's crossing the y-axis, so let's just say 2x plus 5, let's cross it like this. This is my 2x plus 5 line. Where it's crossing the y-axis, at this point here, x is equal to 0. Yeah, y isn't equal to 0, but x is equal to 0. This is our x-axis. So at this point it crosses y, x is equal to 0. But remember, this number here is our intercept on our y-axis. We know that already. That's a fact. So we've said that x is equal to 0. So this is our x coordinate. So x is equal to 0. This is where it's cutting the y-axis. So we've got 0, 5 for where it cuts that y-axis. Now, where it cuts the x-axis, so this is where it's cutting the x-axis, and hopefully you can see that at this point here, y is equal to 0. Okay, so y at this point here is equal to 0. So this means we can rewrite our equation. Y, which we now know is 0, is equal to 2x plus 5. And now effectively we're just going to solve a linear equation. So I'm going to get rid of this 5 by taking 5 off each side. So I've now got minus 5 is equal to 2x. I don't need to know what 2x is, I want to know what 1x is. So I'm going to divide both sides by 2. Well, half of minus 5 is minus 2.5. So x is equal to minus 2.5. So I've got minus 2.5 here. And my y, we know, is equal to 0. So minus 2.5 and 0.